Hey, how's it going, everybody? I hope you're all doing well. And this is going to be the next stream, which I'm hopefully going to be doing chunk serialization in this one. So what I got to in the last stream was basically the ability to load a bunch of chunks. And how's it going, Flare YouTube? I hope you're doing well. Good morning to you too. I'm doing all right. I hope you're doing good too. And I'm glad I'm not the only one who it's morning for, because I always wake up kind of like 9 o'clock isn't too early, but it's pretty early for me. But yeah, so in the last stream, basically got this chunk generation going. It doesn't look the greatest right now because we don't have any sort of lighting, so you can't really differentiate between grass or like the different cubes and stuff. So I want to add in some ambient lighting, but more importantly, I want to add in chunk serialization, because the first time you run this, it takes quite a while. And how's it going, Voxel Riffs? Hope you're doing well also. So first time you run this, it takes a pretty long time, and that's most likely because of in our chunk generation, we have this thing up here, which is the simple X noise generation. Yeah, right here. So the simple X noise is fast, but it's going to be slower than loading from disk. At least I'm pretty sure. And that's good to know for YouTube. It's 9 o'clock for me, so pretty early. I guess it's not too early for you though. So yeah, basically we just want to get this to be loaded from disk instead of having to generate it every time. And then that will also set the path for when we actually are able to change chunks and everything and get all that stuff going. So what I plan on doing is just dumping the binary data of the chunks directly to a file, which should be pretty easy, because if we look at what the chunk is, it just consists of this, right? This is just 64 bits each, and it's just an ID, a light level, rotation, and padding. So that means I should be able to literally just dump the binary data of whatever our block array is, and then I'll probably have like 2 bytes at the beginning, which is going to be like the XY position of the chunk, and then it'll just be like a big blob of all the blocks. And then if I want to store multiple chunks, then I'll just do another XY after the blob, and then just another blob. And that way we can store multiple chunks for a file. So it should be pretty compact. I don't anticipate it taking up too much stuff and everything, so we'll have to see. And I am from the USA for YouTube. I'm in Tennessee, so. Okay, so we just have to write a binary file in C, which isn't too bad. C++, I guess, but in C. So first of all, I'm going to remove that because that's included in core anyways. And I think we're going to have just a void serialize. And then I guess we could give it a file name, but I don't think that matters too much. Maybe we do give it like a const char star world path, or like a world save path type thing, so that it saves it all in one world, because the chunk name is going to get generated just based on the X and Z coordinates. But yeah. And you're from Brazil. Wow. So Brazil is pretty close to USA, I guess my time. I wasn't expecting that. But yeah, so we'll basically have the serialize function, and then we can also have a void deserialize, and this will just take in a const char star world save path. And then maybe like int chunk X and Z. That way we can find the correct file, because we'll be using these X and Z coordinates to do the reverse. If we do multiple chunks in a file, we'll have to sort of figure out which area it's part of, which I have an idea about doing all that stuff, and we'll talk about that a little bit later. But yeah, for now, let's just implement this serialize and deserialize to make our lives a little bit easier. So going to go into the chunk file here, and I'll go right down here. And then we'll just implement this real quickly. So that's just gonna be chunk serialize and chunk deserialize. So for the serialization, and I'm actually gonna move these so that I have it the same in my implementation as my header. Okay, there we go. Yeah, cool, so they all match. Okay, so basically what we're gonna do is just when you open a file in C++, or I guess in C++ it's a little bit different, but this is typically the easiest way for me. You just got a file pointer and you say fopen, and then you just give it a file name, which in our case is going to be, maybe we won't do like a const char star, but just a const stud string ref, because I mean, I guess since I'm using C++, I may as well use like actual C++ stuff. So change that up, and then that way we can do string concatenation too. So change that, and we should be good. Cool. So then what I'm going to do is say std string file path is world save path, and I guess we should probably do a std file system. Nah, we'll just do std string. File path equals world save path plus slash plus, and then we'll do a std2 string, and we're gonna do the chunks, I guess this position, what I call it, I think it's like X and Z. So chunk has world position. Okay, so we'll say world position dot X, and then we'll do a plus underscore plus std2 string world position dot Z. Okay, so what this is going to do is it's basically going to give us a file path that's the world save path slash, and then we just get XZ, and I guess that's a Y, not a Z, plus, and then I'll give it a file extension of just like a bin. It's just a binary file. So we can then open that file path, and we'll give it a mode of write bytes binary. I'm gonna have to Google this one because I always forget. But yeah, how's it going, SE Woods? I hope you're doing all right too. So I'm gonna go just Google fopen real quickly because I always forget this. Okay, so we can do R for reading, W for writing, so that's what we want to do. W plus for writing and reading, but I believe we can like open a specific mode too. Let me go to, yeah, this one. Say what we want to read, and then, or we want to write, and then you can use fputs to put stuff into it. I swear there's like a binary mode though. Maybe I'm missing something. Here, fopen binary file. So, yep, no, I don't think it matters. I think you just literally use this, and then you can just use binary and it works the same. So we should be good. Okay, anyway, so we'll just use W for write, and that should be good. And this is going to be a C string because fopen is a C function. And then we can use fputs, which is just put string. Okay, yeah, and that just takes in a const char star buffer and a file pointer. So I'm literally going to try and do this the easiest way I can. And SE Woods, I will not be able to stream tomorrow because I'm going to be out of town. So yeah, I had to move it up a little bit, but I am going to be doing like 3 random streams throughout next week, probably around 5 p.m. Central Standard Time, because Twitch, to become a Twitch affiliate, you have to have like 7 streams in a month or whatever. And I haven't quite reached that yet. So I'll be doing just some random streams around 5 p.m. Central Standard Time, depending on what time I get home from work and everything. So there will be some extra ones. And it might not be 3. It might be like 1 or 2, depending on how many I feel like I can do. So, but yeah. Okay, so we got a file pointer, and we've opened it for writing, and then we just want to put some strings. And Langors, any reason to use the C library for file manipulation instead of using the C++? I just feel like the C library is easier. So there's no specific reason. You could use the C++ one if you want. I guess there's probably added safety or whatever because they add some extra stuff, but this is pretty straightforward. You just get a file pointer and then you just put S and then you write to the file. So yeah. If I was going to do like file streaming or something, I'd probably use C++ just because I think they have better streaming support and stuff. Yeah. And SE Woods, do you consider streaming games at any point? I've thought about it. Still kind of thinking about that. I'm not sure how interested like most of the people who watch my videos and stuff would be in just watching me play games. And I have no idea how that would go, but I might experiment with it this week since I'm going to be doing some extra streams and stuff. So. Okay, so we just open this, and then I'm literally just going to try and put whatever our binary data is. I feel like there was like a binary mode. Maybe I'm thinking of the C++ version. But anyways, so we store our data just in a block pointer. Okay, so what I'm going to do is say f put s, and first we'll put our x, z position. So we'll say x and file pointer. And this is going to give us a, yeah, because it's not a const char pointer. Okay, let me see if I can just write binary data. C write binary data. Okay, so yeah, so you do RB. Okay, that's what I thought. And then fread, what about writing? Okay, so to write, you do WB. Okay, so B is for binary. And then you just, okay, and then you do fwrite. So yeah, I knew there was something else. I'm like, this doesn't feel right. There's usually a B there. Yeah. And okay, yeah, to use the binary mode, you just use B. Yeah, thank you, Langors. And Player YouTube, your programming skills don't live without my tutorials. If you try to program without seeing a tutorial, they die. If that's how I was at first too, but once you just start doing projects on your own, it does get easier, I promise. So you have to start doing projects on your own and stuff and just sort of struggle through everything, and then it eventually gets easier. Okay, so we use fwrite instead. So this takes in a buffer, which is going to be whatever we're writing. So in our case, that's just going to be like world position dot x. Or I guess we could, yeah, we'll do world position, and I think we can just do like the IVEC too, because I think this is plain old data, so we shouldn't have to worry about this like doing any weird stuff. So I'll just do the address of that, and then the size is just gonna be size of GLM IVEC2, and then element count is gonna be 1 because we're just writing one of these, and file, we're just gonna use our file pointer. Okay, so we're gonna write the world position, and then we're gonna say fwrite, and then we're gonna do our blocks, which is just chunk data. Okay, so we'll just say chunk data, size of block times however many blocks we have, which is, yeah, chunk width times chunk height times chunk depth. So that's what we'll use. So we can just say chunk width times chunk height times chunk depth, and we're just gonna do one of those, and we'll use the file pointer. Okay, so that should write a binary file with all of the chunk data. We'll have to see if that actually works or not. And then to deserialize, it should be just as easy. We can just say get the file path once again. Probably a good idea to make like a helper function for that. Static std string get formatted file path, and then that will take in a string world save path. I like doing this for small functions and stuff whenever I have something where I'm like formatting a string, just so that I make sure it's the same every time. And then I guess this will take in a const chunk ref, which is the chunk. And then we'll just do this as the chunk dot world position. Yeah. Okay. So that should be good. And then we can do, instead of this, we'll just say get formatted file path, and we'll do this and world save path. Okay, cool. That way it's the same both times. We don't have to worry about that code getting duplicated. Do I have any tops for you to stop that, Flare YouTube? Just start doing projects on your own. The more projects you do on your own, the better you get at doing projects. So it's going to be hard at first, and you're going to have a lot of errors and stuff. But when you start running into the errors yourself and figuring them out, you get more experience, and then it just gets easier as time goes on. So it will be hard at first, but you'll get better at it. Okay, so when we do that, we also need to close this too. So we'll say fclose file pointer after we finish writing it. And then for this, we'll say file star file pointer equals, open that, and we're going to read binary. And then we'll say fread buffer element size file stream. Okay, and I think fread increments the cursor every time you do it too. And yeah, no problem. And how's it going, Hilbert Curve? I hope you're doing good as well. Would definitely watch gameplay streams as well, but please not Fortnite. Everybody streams Fortnite. Yeah, don't worry, SE Woods. I would never stream Fortnite either. I don't think I've ever played it, and I don't know how to play it if I did. I've been working my way through Dishonored 2, though, and it's a fun game, but like I feel like I have to concentrate a lot while I'm playing it just because there's so much going on every time. And I reload a crap ton because I don't like it whenever my stealth starts going down. So I just keep reloading until I get the world perfect. Yeah. Dishonored is a great game too if you guys haven't played that. Okay, anyways though, so for reading, we're going to say buffer. So we need a buffer, so we'll say glm ivec2. Actually, we don't even have to do that because we already have it. So we'll say and world position. And we're going to say size of glm ivec2. And then element count is 1, and then file pointer. And that should increment the cursor. I believe that's how fread works. And broadcast your projects. That is sort of what I'm doing with this Minecraft clone. So, and then fread, we want to do, so we got world position, and then we also want the chunk data. So first we have to allocate some space for the chunk data because I don't think that happens automatically with the way we generate our chunks. So we'll say chunk data equals alloc mem size of block times all this stuff. And we'll just cast that to a block pointer. Okay, and then we can just say fread chunk data size of block times all this stuff. See, this is something that I think would be good to have as a constant. I think I do, and I'm just not remembering that. Okay, and then we'll just read it from the file pointer, and then we'll say fclose file pointer. Okay, so serialization in C++ is really simple as long as you keep everything as plain old data. As you can see, you can just write, and then you can just read it. And it just kind of works. And you might need projects that you've already finished that you like the results. I don't know if there's any projects that I finished that I really like the result and stuff. I mean, I finished a lot of projects, but typically it's not to my satisfaction. I don't know. I'll probably stream throughout the week. The one project I'm working on right now, which is my math animations library, maybe. I think I might just keep streaming this one because the faster I get this to a state of completion, then the faster I can start making YouTube tutorials about it and stuff. So yeah. But yeah, if I think of any projects that were pretty cool, I might stream and just have like a stream where I go through all of my old projects and stuff and show you guys what I've done. So, okay. So let's see if this works. If we go into our world, we're going to change up the way we do this a little bit. So instead of just creating a chunk index or yeah, all this stuff. So instead of just generating the chunks manually, which is what we're doing here, we'll say, and let me just make sure I didn't miss anything else too. So we also have the render data, and that is generated in here. So we're going to have to change this up a little bit because this generate function is doing a few different things. Yeah, so this is actually generating the stuff, but then after it finishes generating, it's generating the render data, which we don't want to happen all in the same function. So I'm going to split this up into two functions and say void. So this is going to be the generate function, which generates the actual like noise and the block IDs and everything. And then we're going to have to like have a build function or something, which just builds the chunk as render data. So hopefully this will work good. Okay, so then we'll just go into chunk.cpp, and I guess I could just close it out here and then say void chunk build, and that should be all we have to do. So then this will go through the vertex data. Okay, so this is where we would use, instead of this, we would say world position .x, and this would be world position .y. And everything else should remain the same. We just have to make sure that we actually build this too. Or I guess we could just call this generate render data. It makes more sense because that's what we're doing. And this is just generate. Yeah, I'll just leave it like that. And you meant projects that you've already finished and that you like the result. Yeah, I could do that too. So like I said, I'll probably experiment with different stuff in the future. Okay, so we've got that split up into two different things. So now when we're going through in the world, if we're doing this, we're going to have to generate it, and then we'll say loaded chunks chunk index dot build, or I guess generate render data. Okay, cool. So now that we have this separated, we should be able to separate it out. Let me just make sure I didn't break anything by doing that. Okay, I did break some stuff. Oh, so this must return what I actually did here. So we'll just say return that, and we should be good. And can I do a tutorial on how to make a 3D mobile game engine like Unity and implement visual scripting like Unreal? That's a lot of stuff. So I have not implemented a 3D mobile game engine like Unity or visual scripting like Unreal, so I don't know if I'd be the best resource for learning how to do all that stuff. But there's got to be some ways that some other people that you can sort of look to for resources. And once you get the basis done, it should be pretty easy. So it looks like I did break some stuff, and I think I know what it is. It's just that I never set the world position in here. Let's see. No, I do. So I set world position equal to chunk X, chunk Z. So something else is going on, which is when we go through here, we say set that to, okay. So that's kind of weird. You would think that this should work right. I'm probably doing something else that I'm just not thinking of. So generate the vertex data, generate the elements, and then we just set all this stuff up and go through and run all this stuff. Let me run this one more time and see what is really going on. And thanks, Flare YouTube. I don't know if I could manage it. I appreciate your confidence in me, but yeah. Oh, I set world pose.y. Well, yeah, I set that to world pose.y because I'm using a vec2 instead of a vec3 for the positions, since the chunks are positioned just like on a 2D plane. But maybe it is that. Maybe I did mess something else there. Oh, I think I see what you're saying now. They're all getting stacked. Maybe? So, yeah, okay. So I've got world position.x and y here because this is just a vec2, or at least it should be. Yeah, this is just a vec2. Still doesn't make sense what's happening though. It does look like they're all getting stacked, so something's got to be going on there too. So this world chunk x and world, oh, it's because of this. I should be using world chunk x and world chunk z, and I should be calculating those here as well, and then using those instead. So that should be that, because that's actually multiplying it by 16, which gets it to its world position. Okay, that makes a little bit more sense. And then change, where'd it go? Oh, right there. And change that. And then we'll have to change this to be world position.x and world position.y. Okay, there we go. At least I'm learning from my mistakes, because before I would have just like done a whole crap ton of code and then messed up later on and seen that and had no idea what was going on. So I'm slowly learning how to develop a little bit better. Yeah, okay. So now it's working, right? Now we just need to see if we can serialize that stuff, which should be pretty easy. So as we're generating it, we should serialize it as well. Maybe. I'll do that for now, and then we can change it up in the future if we need to. So for now, we're just going to do this, and then let's just say loaded chunks, chunk index dot serialize. And then for the world save path, I'll just say like world slash, or I guess no slash, since the slash gets appended. And how many hours of stream today? Probably like an hour and a half or 2 hours. Like I said, I want to try and get some ambient lighting going on in here and also get serialization done. Okay, and serialization would be working if I was doing this all right, but something's happening. Once we get this fixed though, I should be done with serialization pretty much, and then we can move into ambient lighting and get some cool stuff going. So we get a file path, which is world slash -4 underscore -4.bin. So that's good. We open the file and then we crash. So it doesn't like writing the glm ivec2, which is kind of weird. Is it because of the way I use this? I'm pretty sure that that should just be 1, but I could have that wrong. So element count. And did I know how to use the Unreal visual scripting or C++? Yeah, this is C++/C right here. And the Unreal Engine's visual scripting, the blueprints are pretty nice. Do you sub to Get Indie Gaming? Really enjoy indie gameplay if the game is good. I haven't heard of Get Indie Gaming. I'll have to check them out. So, yeah, I sub to a lot of other people though, like that do some gameplay related videos. So it just depends. Let me see if I'm doing something wrong with F-right. So this says count number of elements, each one with a size bytes. Yeah, which is this. And then size t is an unsigned integral type, so that should be fine. So they're saying we should basically be able to just say buffer, size of char, size of buffer, p file, which is fine because, yeah, what I'm doing is size of glmi vec2, and there's just one of those, so I'm saying 1. Yeah, so that should all be okay, I would think, unless this is failing for some reason, which it very well could be. Let's go back to fopen real quick. Yeah, I think that's what it is, Langors. Thank you for mentioning that. Does the folder exist? I think that's probably what's happening is the folder doesn't exist, and it's just, it doesn't like me because of that. I'm going to go ahead real quickly and go to my math animations library because I made some helper functions for file management, which would probably be helpful here. Not in there, but if we go in here, I keep playing around with whether I want to use like the standards file system or whether I should just code my own, because coding your own doesn't take too long. So yeah, I've got this file.h and it's really simple and it is pretty nice. So I just have a few helper functions in there and then I'll probably add to it as it grows. But yeah, so we'll put this inside of core.h, I guess, core. So I'll go ahead and say file.h. And for that, I'll just paste that, and then we'll change this to Minecraft. And then down here, I'll change this to namespace Minecraft. And then we'll just change all of these to be like C++ casing. So I'll change that to that. And then that. Cool. So we've got all this, and this should be namespace file. Okay. So that should all be good, and I'll copy the implementation real quickly. And you can't find tutorials that work properly. What do you mean by that, Flare YouTube? Most of the time, well, a lot of times with tutorials, you kind of have to do some modification depending on your system. So that's part of the process of like learning how to code a little bit better too, is debugging and stuff. Because when you're coding in like a job setting or anything, you typically have quite a lot of debugging. So it's a good skill to learn if you can. Okay, so we got that in core, and then I'm just going to go into here and say file.cpp. And then I'll just paste that, and I'll just change this up a little bit. So this will be core/file, and I'll say hash include core, and that. Okay, and so this is just like Win32 stuff. So because I'm using Win32 API directly here, and then if in the future I wanted to add support for Linux and other systems, then I could just change it up in here and add more implementations. So yeah. So I'll change this to file, and I'll just go down here, fix that up, and then I'll just change all of this to match the casing I had in the other file. Okay. And then I should be able to just create that directory and fix this up and use this instead of what I have been doing. So fix all that. That and that. Okay, cool. And ST Woods, you said you're currently working in Eclipse. Have I used that or always IntelliJ? Yeah, I've used Eclipse before. I think that's what I started with. But after my first internship, I was introduced to IntelliJ, and I just didn't want to go back to Eclipse. It always gave me such, I don't know, there was just a lot of problems with trying to use it and stuff. But with IntelliJ, it just sort of worked, which was nice. So nothing bad about Eclipse, though. I mean, if you can make it work and stuff too, then go for it. Should work fine. Okay, so inside of here, we're going to go ahead and say include core/file. Okay, and then down here, I can just create it if it doesn't exist. Or actually, I guess not in here. Probably a better idea to do this inside of the world when we're initializing the world. Okay. So now, finally, I can just say file create if not exists, and then we'll just do world. Okay, and that should just create the directory, and then hopefully we won't get a problem here. Because I think you were right, Langors. I think it's just a directory doesn't exist thing. So if I jump into here, okay, yep, so now it's working. Cool. So I'll just hit continue, and we'll go ahead and finish that up. So this should give us some binary files, and we'll inspect the contents of that in just a second, just to make sure that it's working right. And you have a challenge. Program something using only one line of code. Well, I mean, if you really want to see that, your best bet is just to code something in TypeScript and then use Babel to cross-compile that to JavaScript and minify it, which will change it into one line of code, but it'll be a whole JavaScript program. So if you're using any sort of web program, that's typically what they do, because when you're coding with JavaScript, you have to make the file as small as possible to make it load faster on websites, since the way a web browser works is it loads the resource and then executes the code. So they typically remove all white space and all new lines and stuff anyways. So any website you go to will probably have one-line programs. That's all JavaScript. Okay, but we should have some files generated. So if we go into world now, we've got a bunch of binary files. Cool. And say we go into, let's go into 1.2, because that'll be pretty easy to inspect. And then I'm going to open up VS Code here, just so that we can inspect this pretty easily. And I'll say open, and I want to open it anyways with the hex editor. Okay, so it doesn't look like we wrote anything. Wait, yeah, we did. Okay, so this is 0, 1. This is the first three bytes or 2 bytes? I can't tell. Wait a second. And then this is 0, 2, which we should be getting, because that's, oh, it's the first 4 bytes. Okay, so the first 4 bytes are 0, 1, which is the chunk position. And then the next 4 bytes are 0, 2. And then this is the first block ID, which it looks like is 6. And then the next block ID is 0. Next block ID is 6. 0, 6. Okay, and what is 6? Let's just make sure that this sounds right too. I mean, we don't technically have to do this, but it's always fun to look at binary and stuff. Okay, so if we look into here, the way we're generating it, do we have any chunk IDs or block IDs that are 6? We do, which is bedrock. Okay, cool. So that's the bottom of the chunk. That makes sense. So it's basically alternating between that and 6. And then if we scroll down, it'll probably change to a different number, which is stone. So it'll probably be 5. If this wrote properly. Yep. Okay. And then we switch to 5. And if you keep scrolling down, you'll eventually get to like whatever our grass block was, or air, which is just 0. So that makes sense too. Let's scroll up a little bit more and see if we have, yeah, well, we probably do somewhere, but you'll also notice too, this is good. So we've got 6, which should just be the first 2 bytes. So that's 32 bits. And then we have the next 32 bits free. And that's because of the way we formatted our chunk. So you can see, or actually I guess just the first byte. First 2 bytes. So we got, that is free. And then the next 2 bytes would be the light level and rotation. And then the last 4 bytes would be the padding. I believe that's how it works. So if we look back into here, this is the first 2 bytes, which is just the ID. And then the next 2 bytes would be the rotation stuff. And then the last 2 bytes Or no, I'm sorry. This is the first 2 bytes. Okay, I'll get this eventually. And then this is the next 2 bytes. And then this is the last 4 bytes. And then we get to the next block, which is good. And you'll notice they line up really nicely. Hopefully this is what will end up happening once we load this into RAM and the cache too. Because these are aligned at 64 bits, each block we'll be able to get like two blocks per cache line, I think, or 4 blocks. Because I think the way CPUs work is you can load like 4 64-bit addresses and stuff. But yeah. And so Twitch only has 1 line of code. Interesting. Yeah, Twitch does only have 1 line of code. So, okay, anyways, though, looks like this is working good. So then if we go to world.cpp and we change this to, instead of generate, we just go ahead and say loaded chunks, chunk index dot deserialize, and then we give it world, and we say chunk X and chunk Z, which is just X and Z. We should be able to deserialize those, and I'm going to remove that line, and it should load way faster because I have a feeling the simplex, yeah, sweet. Okay, but did we get them? No, because I forgot to do this line of code as well. So if we do those 2 lines of code, we should get some pretty fast loading. Nope, still taking a little bit, but I think it's definitely a little bit faster. And I also have to fix the way we deserialize because what's happening? Let's just make sure this is all working right as well. It's almost there though. Have I ever done anything in machine code? Do you understand any of it? Not like modern architecture machine code stuff, but I've done like MIPS, which is just a simplified assembly language. And we just did that in college when we were learning about like, I can't even remember. It was just like computer architecture or something. But if you do any programming in like x86 or any other sort of assembly, then you'll probably get some experience with like machine code, because once you're in assembly, it's literally just one more step and then you're in machine code. So I think like cyber forensics and stuff, they look at machine code to trace back how they got to a particular point. And that's just insane. I don't know how anyone could do that. Okay, so something's going wrong in our deserialize step. So I wanted to put a breakpoint here and see what exactly is going on. So if we step into here, we get the file path, we open it, and what world position do we get? So we have chunk X is -4, -4. So we should get -4, -4 inside of world position. Do we get that? No, it doesn't look like we did. Yeah, and see, this is what I was afraid might happen. I don't think this is getting read properly because of the way a GLM IVEC2 works. I don't know. That's still pretty weird, though. I would assume it would still get put in there. Let's see if the chunk data... I think the chunk data is getting put in there fine. If we take a look here. Yeah, so we get 6 as the first ID. So that makes sense. So what we could do, just to simplify this, is literally say size of... What is it? We're doing an IVEC2, so I guess that would be 232 bytes, so 64 bytes. Or 232 bits, so 64 bits, but yeah. So if we go into the serialize method, we should be able to just, instead of doing this, say size of int 32, and then we'll do 2 of those. And I mean, I guess I'll just do 1 of those. So what I'll do is I'll just say this dot x, and then we'll just do this twice, and then dot y. And then when we're deserializing, we'll say int 32 x z, and then we can just say x size of int 32. We'll read 1 of those, do that twice, and then we'll put it in z, and then we'll say world position equals xz. Okay. See, this is what happens when you don't have plain old data in C++, is you can't do things like this because constructors and all that will do weird stuff. So then you have to actually construct the object to get it to work right. So if I were to do this now, it looked like it serialized fine. So I don't think there's any problems with that. But now if we go into this deserialize function, hopefully x and z, we get -4. Nope, we still got 0, 0. And it should be -4, -4. That's weird. Int32 is a 32-bit int. That is correct. So, but I'm not sure why it's not reading it into here. Yeah, so then if we look at this, this is just going to be 0, 0. Did I get the right file path? Is that why? I don't see why that would be a problem, but if we look at -4, -4, and then I open this up in VS Code, let me just make sure that that's serialized correctly too. So if we look into here, okay, we get this FC, FF, FF, which I'm assuming is correct. We can double check that real quickly and just say like hex to int32. And then we'll make sure that this is working right. So this says all of this stuff. Okay, yeah, so we got -4. Okay, yeah, so -4, -4. That should be fine. So, not sure why it's reading it weird. And then once we get to the chunk data, it's working fine again. Okay, I'm gonna have to think about this for a minute. I have many tabs open. That's called high IQ research. I hope that's what it means, but I think it really just means I'm lazy. I've also got extra tabs over here too, which is why I like Opera. So I have many tabs, many open. It's not a good habit to get into. So we got world position, and it should be reading it into this X variable and this Z variable, but it's not. I'm not sure why. Let's see what fread says. Let's look at the documentation. So this says pointer to block memory, size in bytes, size times count, which if we look at this, what we had open, that is 1 int32. So 1 times size of int32 should give us 1. That should be fine. Number of elements, pointer to a file object. So this says we open it. I guess I should probably check if it's null to make sure that we don't have an error there. This is just to get the file size, but I don't care about that. And then this says use put s. Okay, so then we can read. Okay, let's check and see if we're getting any sort of weird errors. So if I go back into here, we can say if not file pointer, logger error could not open file, and then we'll do %s, and we'll say world save, or I guess file path dot c string, and then we'll just return. Okay, let's see if we get an error, and maybe that's what's going on. YouTube, Twitch, and WhatsApp. I wish I only had 4 tabs open. Okay, so we open it. Okay, so we're getting an error. I wonder why we're getting an error. Could not open world/00.bin. Do we have a world00.bin? Okay, we do. So that should be fine. Oh, I said if FP. I should say if not. But wait a second. Why is it opening 0, 0? I thought that was like -4, -4. I think this is our problem. So it was going right. Okay, so this says -4, -4. Okay, but get formatted file path is taking... Okay, I see what's going on now. Oh. So let's change this up to, instead of taking a chunk, int 32x, int 32z. Okay, so it looks like our thing was working perfectly fine. It was just opening up 0, 0, which is why I was seeing zeros there. I had a feeling that might be what it was, but I wasn't completely sure. I should probably have checked that. But anyways, if we just change this to that, and I bashed GLM for no reason then apparently too, because this is not what we need to do, because they do have plain old data, which is what I was pretty sure. We should be able to do this, and then just change that back to GLM IVEC2. Should be fine there. And this will now take in chunk X, chunk Z, and we should be good. Okay, there we go. And I'll have to abstract all that stuff in a future episode or something too. So then instead of doing this, we can just do fread world position, and then we'll do size of GLM IVEC2 and 1, and then we'll just give it our file pointer. Okay, cool. So now if we do this, it should work fine. Yeah, so then if I go into here, we open it fine, and if we look at world position, that is -4, -4. Okay, there we go. So we should be good now, and then I can just remove that and play it, and we get our chunk. Sweet. Okay, cool. So now we have serialization. That was easy. I guess the stream is over now. No, I'm just kidding. So that is how simple serialization can be if you actually serialize and deserialize the right values, as I just showed. But yeah, so we should be able to get that. I can't tell if this is any faster than generating. So let's see. If we run this with generating, let's guess how long it takes, I guess. We'll just see how it goes. Yeah, that stream was fast. No, I'm going to do ambient lighting too. So it does take quite a bit to use all the simplex noise, and then it loads. What about when we switch to just using deserialization? So now when we run this, it should be a little bit faster. And it goes, still takes a little bit. Okay, yeah. I think that is just a little bit faster, but I'll talk about what my idea is too. I'm going to switch to the drawing screen just so that you guys can see what I'm thinking about. So basically, what I'm thinking is we're going to have sort of these chunk areas. So we're going to have chunks, which are the individual graph squares here. So that's one chunk. And we'll basically load in like a 4x4 or a 5x5 area, and that will be called like a chunk area. So one of the big blocks is basically going to be an area. These are what we're going to be like serializing out to disk and deserializing and stuff, because opening files can take a while. So if we do a bunch of chunks in one file, should load a little bit faster. But not only that, what I'm going to do then is I'm going to have 9 areas loaded in around the player. These are all going to be loaded into RAM, which shouldn't take up too much RAM. But then we're only going to render the chunks that the player can see. So like if the player is pointing this way and his render chunk distance is set to this, we'll only be loading like these chunks here, or rendering those chunks. All of these chunks are still loaded, and they're still like running in the background and everything, but we're just rendering whatever's in this blue area. That way, if the player is moving super fast and he moves over to here, then we just load up this part, and then we unload this part, and we should never have problems where like you're moving too fast so that the world can't load. That's my goal, at least. I want to make it so that you can move as fast as you want, and the world should load pretty easily. And also, like once you move over to here, if these chunks aren't generated, it will generate them and then serialize them, and then it will keep them loaded in RAM. So that is the plan. We'll have to see how it actually goes, because I have no idea how that's going to work. Well, I mean, I have an idea of how it's going to work, but I have no idea if it's going to work. Okay, so now that we have that done, I think it'd be a good idea to work on lighting, just some basic stuff. And will this game have support for mods? Probably. I don't know. So I haven't really thought about that too much, but if it did, it would probably be in like C++. And then you would just call like a C interface that interfaces with the game. Because the way I'm coding this, it should be really easy to make just a bunch of C interfaces for all of our functions and not have to worry too much about that. So yeah. But let's work on lighting, which is something I have opened up here. So we're going to add in ambient lighting and diffuse lighting. So that basically means like sunlight and moonlight. And that way we can get clear defined edges on all of our chunks, because right now it doesn't really look like much. I mean, it looks like much, but you can't really tell the boundaries of like the cube's edges and stuff. So yeah, basically we're gonna have to store normals though, which is this. So you have a normal and then the light bounces, and then you can calculate like how close together it is and stuff. So first thing that we're gonna have to do is go into our vertex definition, which I believe is right here. And we're gonna go ahead and add in something else here, which is just a vec3, and this is gonna be our normal. So each vertex will have a normal associated with it. That way we can calculate what the light direction should be. And then if we go into chunk.cpp, we're gonna have to change the way we generate this stuff. Yeah, so that's all fine still, but when we actually upload it to our shaders and everything, yeah, right here. We bind all of our data, we buffer all of our data, and then we're gonna have to say, add in something here, vertex attrib pointer 0, this is gonna be 3, it's gonna be a float, false, size of vertex, and then we're gonna use void star, offset, vertex, and normal. Cool. So then this will be GL vertex enable vertex attrib array 1. So this should be 1, not 0. Whoops. And then I spelled this wrong or something, so just fix that. Okay, there we go. Cool. And then this will now be 2 and 2. And then let's open up our shader inside of here, because VS Code is much nicer to look the shaders in. So just drag and drop this. And it looks like it put it right here. Did it? Let me just close that out, because I think that might have been a different one. Nope. Is it not going to open it up for me? Yeah, that's weird. Okay. Let's go open folder. And I'm going to go to this and right here. Okay, this is weird. I don't get why it's asking me all this stuff now. Didn't used to do that. Okay, anyways, though, this is our shader. And we're going to have to modify this a little bit. And SE Woods, just a hypothetical question, but if I got presented with some solid work regarding a game being developed and I got offered to join the team or to be hired to do a specific task for money, would you have considered it? I don't know. It's difficult. It'd have to be higher than my current salary, because I don't think I'd just switch jobs, because game development and stuff is typically volatile. Like, there's a much higher risk of you being fired or whatever, or not fired, but like just the game failing, all sorts of stuff. So I'd have to definitely be paid up front. And I don't know, I would hope that there'd still be a work-life balance, because that's the other thing with game development, is it's typically like they don't let you just work 8 hours a day. It's more like 10, 11, 12 hours a day with the indie companies and stuff. So I don't know, it's tough. And you usually get paid a little bit lower too. So I think I would do what I'm doing now and just stick with a normal software engineering job where you typically get paid more, you work less, and then you have time to do your side projects, which is what I like doing anyways. So yeah, it's difficult though. I mean, because game development is more fun. And Langor says you need to add support for transparency in the render, and for that usually need transparent blocks. Oh, yeah, I didn't even see that, Flare YouTube, sorry. But yeah, so is it hard to make glass blocks? So you need to do tricks in the shader so you don't need to sort them, is what Langors is saying. I'd be interested to hear about that, Langors. If you have any links or something, you should paste them in the chat so I can look that up later, because I have been wondering about that. I didn't know if you would do like a separate chunk for like transparent blocks and then do those afterwards or anything. So I'd be interested to see if you have any good stuff on that. But for this, I'm going to say layout location equals 1, and this is going to be a normal, and 2 is now going to be our text chords. And then we're going to say out vec3 f normal, and we'll just say f normal equals a normal. And inside of here, we'll just take in a vec3 f normal, and we should be able to use that normal and calculate some light. So let's look at Learn OpenGL and see how they say to do it. So first of all, they say ambient lighting is really easy. You just have an ambient light strength and then a color. And then you just do this, which is pretty true. Like if you just want some sort of ambient light, that's how you do it. But we want diffuse lighting because that's where you get like edges and stuff defined. So we basically need normals, which I guess we should probably generate those inside of the trunk as well. So we set the positions here and we load the block here, which I think this is where we would probably load the normals into. So this is going to say, yep, this just sets the UVs and everything. And then I guess we could just say vertex data, vertex cursor plus 0 dot normal equals. And then what I'll do is I'll just have like a face passed in and we'll be able to like get the normal from that. So we'll say glm vec3 normal equals get normal from the face, and then we'll just say normal, and then we'll just do that and set the normal to the same thing because we just have cubes, which means we don't have to worry about anything fancy. And S.E. Woods said, you understand, but did not mean that you would have to quit any job, more like hired work for a week's worth of work. That's difficult too, though, because even if you're not quitting the job, like that's still, I mean, that's like work on top of it, and it probably means that I'd have to stop doing my side projects and stuff. So yeah, I think it would definitely be a no in that case, because if I have to work and then do double work for another job, even if I'm getting paid, it's just not worth it to me because I like still having like off time. So I don't program too much outside of work, and I still go out on weekends and stuff. So it's like, it's just a little bit too much time commitment for me. But yeah. Okay, so let's add in an enum for a block face. So we'll just go up here and, oh, we already have that cube face. Cool. So I'll just use that. And we'll go into here and just say this also takes in that. And I'll scroll up and fix the forward declaration too. Yep, so we can just change this. And now all of these functions are going to be broken because we need to pass in the face as well. So let's see right here. Yep, so then we can just say cube face top. Cool, and then we'll do the same thing here. We'll say cube face bottom, and right here would be cube face right, and this one would be left. So this is all some pretty basic stuff. This one would be forward. Nope. I guess I called it front. What'd I call it? Did I not add it? Got back, bottom, left, right, side, top. We don't have front. So I'll call that front, and then I'll have to add that in. And this one is cube face back. And that should be it. Cool. So then we should go over to here. And this is just going to be front. So top, side, bottom. We should just have 6. There's only 6 faces on a cube. Top, side, bottom, right, left, back, front. We don't need this side. That's 1, 2, 3, 4, 5, 6. Okay, there we go. So that's right. And then if we go down here, we can just add in a function that does that really quickly. What's this saying? Offset is, offset of is what that should be. And then down here, we'll just have a static glm vec3 get normal for a cube face face. And this will just switch on the face. And if we have the front, we return glm vec3. I think it's X is our forward face. No, I think X is, yeah. So I think that's that. Let me just double check real quickly. So right face is X, Y, Z plus 1. Okay, so yeah, Z is right and left, and X is forward and backward. So we would just do that, and this has to be cube face. Yep. And we'll just copy that, and we'll do back. and this will be -1, and so on and so forth. And languors. Thin matrix explains what you were trying to say much better, the OpenGL series tutorial 15. But basically, if you have either full transparency or no transparency at all, you can just discard the fragments in the shader. But if you have objects with semi-transparency, you need to sort those first. Yeah, so the problem with that, though, is just if you do discards in the shader, that can negatively affect performance. Just because it basically disrupts the flow of execution for the parallelized like the cores on your GPU. So yeah, but learn OpenGL. Yeah, learn OpenGL does have that too. I'll check out the advanced OpenGL section for blending though, because I think what you're talking about where you sort it and then you just sort of turn blending on is probably what I'm going to have to do. So basically we just sort the vertices and stuff, and then when you render it, it automatically gets blended. Okay, so then for this, paste that one more time. We'll do left is 0, 0, -1 here. Right is going to be 0, 0, 1. And top is going to be 0, 1, 0. And then bottom is going to be that. Okay, cool. So now we can get a normal and we can assign all of our normals. So we should have that inside of our shader, which is good. So we basically have our normals available now, and we have this vertex attrib pointer. What's he doing? So he's just enabling it. And then he just sets the normals here. So that's all fine. And then we get the vec3. Okay, yeah. So now we need the light position, which is basically just going to be our sun position. So if I just go back into here, I'm going to have a uniform vec3 sun pose. I'll do sun position. And this is going to be U sun position. There we go. Cool. So we have the sun position, and then we can sort of go through it. We'll have to upload that and do what he's going to do here. So he just sets it in his shader. And then he says position, frag position, normal. Okay. There we go. So then, wait a second. So he's getting the fragment position too. We might need that. Okay. So he gets the frag position, which is basically the model times a position, and we don't have a model coordinate because it's just sort of embedded in our view. Trying to think if this is going to affect things. I think it probably will. So let's see. We basically have our projection, our view, and then our position. And so to do the same thing he's doing here, he's just doing the model times the position. Well, our position is in world coordinates, so we just pass our position, and that should be fine. So if I go into here, I could say out vec3 f frag pose. I'll do position, be a little bit more explicit. And then we should be able to just do f frag pose position equals a pose. Yeah, I think that should be fine. Let's see, what does he do? One more time. Yeah, so he just does model times a pose. We don't have to do the model because our stuff is in model coordinates already. Because it is in world coordinates, which means that, yeah, this is just okay, that's just turning it into world coordinates. So we should be fine with that. Okay, cool. So then in here, we can just say in vec3 f frag position, and we have that available to us now too. Then he gets the normal, which is the incident normal, so the normal between the sunlight and whatever position. So he says it's normalized the normal. I'm not going to do that because it should already be normalized. And then we're going to do light direction in here. So we get the light direction. I'll zoom this in a little bit too, which is going to be the light position minus the frag position. So change that and change that. And then we get the diffuse, which is the normal dotted with the light direction, maxed out to 0, and then just times the light color. Okay. So yeah, I'm just copying and pasting for this, which is a good way to do things when you're just starting out. I'm not too familiar with like lighting and stuff and rendering in general. So this will just use F normal instead of that. And we have light direction there. And we'll just get in a uniform. Well, actually, I'll just do for now vec3 light color equals vec3 1 1 1. So we'll just have like a white light for now, and then we can change that later. Okay, so then we get the ambient plus the diffuse times the object color, and we just output the result. So I'll just do diffuse times the object color because we don't have any ambient light technically. So we'll just do that. So just the diffuse times the object color, and object color is going to be texture, u texture, f text chords, dot xyz, or I guess we could do RGB, and then we can just do, oh, I should change this to out color, since actually no, I guess frag color still does work. So that's like the color that we're outputting, and then I'll just change this to vec4 result and 1. Okay, cool. So that should be diffuse lighting. We should just have it kind of work. We need to upload the sun position. So if I go back into world, which is where I think we render, we basically say, nope, I think that's in the render, which would make sense. So if we go into renderer.cpp, nope, if I can spell right, render, maybe we just have that in the chunk. Yeah. Okay, yeah, so we just have that right here, but we're not uploading anything to our shader because that's happening inside of, let's see. Not quite sure. I think that is happening in world. Let's see. So, okay, yeah, this just loops through the chunks and then renders them. Okay, and I bind the shader up here. Okay, cool. So then what I can just do is say this, and I'm going to change this too. I just need to change the way this works and stuff. But anyways, upload a vec3 shader u sun position. And then we'll do a glm vec3. And I'll say like 1 0.5f 1, which isn't going to be very good. I should probably make this like 250, or actually like 355. So it's going to be like way up in the sky. And hopefully that'll give us some good results. Okay, so let's see if this works. I have no idea what's going to happen. We're going to get breakpoint. So what's happening here? Looks like we're not finding the sun position. Is what I'm guessing. Wait, no, okay, I just have an error. Expecting comma or semicolon at token texture. So that is right. Did I miss a semicolon? Let's see. So wherever texture is, that's where something is happening. So we got texture here. Okay, right here. Oh, I need an equal sign. That's helpful. Cool. So now we should be good. Let's just rerun that real quickly. And how's it going, Ike? Good to see you. We should hopefully be getting lighting going in this Minecraft world. Or I might have crashed it. I'm not sure because it's taking a lot longer than it usually does. Oh, it's because of this. Yeah. Windows has to fix their command prompt because it shouldn't stop your whole program when you just click into it. It's just weird. Look at that, guys. We have ambient lighting. Now it's actually starting to look like a chunk. And you're making some pizza dough. Pizza sounds good, man. Wow. It's very dark, but hey, it's kind of working. I have no idea. It's probably because I don't have any ambient light, so I should probably set that up kind of good. Actually, no, I think this is what it's supposed to look like with just ambient light because it's just making it darker. We can lighten it up a little bit though. But yeah, this is good. We got kind of shadows, which makes it look a little bit easier to define the cubes and stuff. So let's fix that up. And yeah, it's finally starting to look a little bit more like Minecraft, right? So let's add in ambient lighting, which he says we can do by doing something up here. It's pretty simple. It should just be, yeah, like, so we just have the ambient strength, and then we just do the ambient strength times the light color. So we can add that in pretty easily just by doing this. So this is our ambient light, and then turn that into diffused lighting. And so we'll set our ambient light level to like 0.8, I don't know, maybe like 4. And then we'll use our ambient light times the diffuse, or plus the diffuse times the texture. Let me look at what he did again, just to get an idea. Or just to steal what he did, I guess is what I'm actually doing. Yeah, so he just says ambient plus diffuse times the object color. Okay, cool. So now if we run this again, hopefully it'll look even better. And it's funny how lines of words turn into a game. That is true. Technically, it's electrical signals, which is even stranger. But yeah, cool. So now it's looking even better with the ambient light added, because we can sort of control how much gets, like how dark it is and stuff. So yeah, that's good. But hey, look at that. We've got like shadows and stuff. And then once we actually add in like light levels and stuff to our Minecraft game, this should look even better, because it'll sort of like add some interpolation. Like what you see happening here is it looks very flat. And the reason it looks very flat is because basically these normals are all 1 and it's pointing directly up. And then these normals are all pointing this way. And there's like no gradient. And so we could very easily make a gradient just by pointing the normals at like a 45-degree angle this way and a 45-degree angle this way. But the intersections might look kind of weird. So yeah, I'll just have to look into that and stuff, and we'll have to figure out a way to sort of interpolate the light level, which is what Minecraft does itself. Yeah, and then if we look over here, we can just see the blocks a little bit better too and stuff. So one last thing I'm probably going to do. And am I planning to add sounds to this game? Yes. You can't have Minecraft without sound, so we're going to have to add some sounds. I'm not sure what library I'll use, but I'll probably explore that in the future. But yeah, one last thing I want to do though is load in a much larger chunk area just to see what our frame rates are, and then also add in fog. So we should have like fog lighting and stuff. And am I a space fan? Sort of. I'm not. That could mean a lot of different things. Like I like sci-fi. I just read The Martian and Project Hail Mary, which are both by the same guy, a little bit ago, and really enjoyed those books. And I don't really watch like the shuttle launches and everything. I'll keep up with them and like watching, and I'll like watch highlights or whatever of Jeff Bezos and Elon Musk and stuff, but I don't actively follow. So yeah, it's cool though. Okay, so let's load in a much larger chunk area real quickly, which we should be able to do just by saying world.cpp. So we'll just add, yeah, let's do like something crazy. Do like a 20 by 20 chunk radius and see how this works. No idea if it's going to go well or not. So we'll do that. Instead of doing serialization, we'll just generate them, and then I'll serialize them so we can load them faster the next time. So let's see how this goes. So this is going to take a little bit longer because we're generating a much larger area, but hopefully we can speed this up in the future using some of the techniques I described a little bit earlier. Okay, still going. I should probably add some progress indicators over here too, just so I know like which chunk I'm generating and stuff. And I'll eventually get around to like benchmarking and everything just to see which parts take the longest. And hopefully we can speed up those parts and stuff. And I forgot to remove the faces between the chunks. Yeah, I have not removed those yet because it's a little bit more complicated once you get to like chunk boundaries and everything, and it's not going to really affect frame rates too much right now. Definitely going to be removing those in the future though. And you're a big fan of personal space. I am too, Hilbert Curve. It's pretty annoying whenever people don't respect that. So what do we get wrong here? I wonder if we're running out of room or something, which wouldn't make much sense because this shouldn't be that much memory. It just says, okay, so what we got VBO. Looks like the VBO messed up. So we've got a VAO of 298, and I would expect the VBO to also be 298, but for some reason it's not doing that. I'm guessing we're running out of space, but that just doesn't make much sense to me because we shouldn't be having that much data uploaded to the GPU. So I'll have to look into that. I'll lower the count for now, and then I'll have to check out what's going on. But yeah, it definitely looks like it was generating all them fine. It got to -10, -10. And it looks like it got stuck at, let's see. Yeah, I'm not quite sure where it got stuck. Because, okay, it looks like we got to 9. And then it got stuck somewhere around here. Yeah. Okay, so I'll just decrease it for now to like 8 by 8, and we'll see how that goes. And then I'll do some debugging when I have some extra time just to see what exactly is going on. So we'll just do logger info for every chunk that we generate. And we'll say generating chunk, and we'll do chunk index. Okay. So put that, actually, yeah, I guess that works right up here. Cool. So we'll do that. We should get like 64 up there. And familiar with neural programming, if that's the correct term. Yeah, so that's like machine learning AI type stuff. I've done a little bit. It's basically just linear algebra when you get down to it. There is like a couple different kinds of machine learning AI that they've experimented with. I haven't kept up with it in a while. Like last time I really looked into it was probably about a year ago. But at that time, there's like recurrent neural networks, which is basically they try and mimic how your actual brain works and stuff, but that's very slow. And then you just have like linear neural networks, which basically don't do what your brain does, but are faster and they give pretty good results. So it's cool experimenting with that stuff. This is really weird. So first of all, let me see. Okay, so it looks like I'm using up 30 gigabytes. So that would definitely explain why it's crashing here, but I have no idea why it's using up 30 gigabytes of RAM. Because it shouldn't be that much memory. Let's do some calculations real quickly. So if we do logger info, let's say what is the %d size of chunk. So we'll say size of block, first of all, times chunk width times chunk depth times chunk height. And I'm going to have to do this inside of the chunk. So we'll just like create a function real quickly. Just call this chunk info. And if we go into here, I'm just going to do a static function on this guy. And then we'll just implement that in here real quickly just to get some information and see what's going on. So we'll say void. Okay, so let's see what's going on here. And 30 gigabytes, yeah, that's definitely not right. So something's going wrong there for sure. And how difficult is it to program while communicating with chat? It is a little bit harder, but it's easier than I thought it would be. So the first time it was pretty hard, and then as I got used to it, it's a little bit easier. It's sort of like when I'm recording my videos, just there's people interacting with me, which is kind of nice sometimes. And you guys give me helpful hints and stuff too. Okay, so we're getting this number for the size of a chunk, which is in bytes. So if we calculate that real quickly, and we just do that divided by 1024. Okay, so apparently the size of a chunk is 512 kilobytes. Okay, so that's not bad. That means if we had 8 by 8 chunk area, we would have 32 megabytes. Not 30 gigabytes. We should have 32 megabytes, unless I'm doing something wrong here. Not calculating that right. And like everyone should have 32 megabytes of RAM. That's not a big number. Okay, so that makes sense. What about, so we allocate memory for the chunk data, which is this thing, which I just wrote right here, right? Okay, yeah. So then we zero that memory. Where else am I allocating memory? Okay, so we also allocate memory for the vertices and the elements. Let's see how much space this takes up. So go up here. I don't think we need the elements too, so I could probably get rid of that for sure. But I don't think it should be that big either. So %d size of vertex pointer, or I guess vertex data. And then let's also print out the size of element data. And then I'll just copy that real quickly too. So this is all the memory I'm allocating. And I don't think it should be that much. Like maybe a gigabyte at most. And we can definitely work that down too. So then if I run this, let's calculate some more numbers. And we have 16 by 16, so it goes from -8 to 6. Okay, thank you, yeah. And yeah, that is still just 130 megabytes. So we still shouldn't be getting that much. Okay, whoa, so vertex data is definitely bigger, and element data is pretty big too. So those are probably adding quite a bit. And I think this is probably the culprit. Let's see, paste that. Yeah, I think this is definitely it. So we'll multiply that by 16 by 16. Divide by 1024, so that's kilobytes, megabytes, gigabytes. Okay. So it's definitely this. So it looks like the vertex data is taking up 12 gigabytes, which is insane. And there's got to be a way we can reduce that. What's taking up so much space in our vertex? If we look at this, we've got a vec3 for position, normal, and UV. So that is 3 times 4 is 12 bytes, 24 bytes, 32 bytes. That doesn't make that much sense to me. I don't think so. Let's see. Yeah, 12 gigabytes. That's definitely not good. So that's 32 bytes per vertex. Let me just make sure that this is all correct. It should be. I don't see why it wouldn't be. And then we have that times chunk width times chunk height times chunk depth times 24. So we have that times 255 times 16 times 16 times 24. Yeah, okay, so that's definitely the right number. So is there any way I can reduce the size of the vertex? And I'm sure there's lots of ways I could do that. So we have 32 bits per coordinate. Do we need that? And we have 32 bits per normal. We definitely don't need that for the normals. Yeah, it took me a while to get up to how much RAM I have, and it's still not enough for this, so it's killing my computer. Okay, what we can do is we can change this to a uint, like 8 is all we need for this, and then we can just say that's the face, and then calculate the face on the GPU itself. With the UVs, though, I'm not quite sure. And I don't know if we can do specific sized attributes like this inside of OpenGL. So if we go back into the, let's see, chunk.cpp. So if we scroll down wherever I'm actually enabling the attributes and stuff. Yeah, okay, right here. So what we could do then is change this to very important, vertex attrib I pointer. Since we're doing an integer, this has screwed me up so many times, and it's so hard to debug when you have the wrong thing. But yeah, anyways, we'll do that, and then we can say gl unsigned short, which I believe should give us just 8 bits, size of vertex, offset of vertex, face. Okay, so then this will be the face instead of a normal. And what's wrong here? Oh, and we also don't need to normalize it since, yeah, this is an integer. Okay, and we just have one of those. So that should reduce it quite a bit. And then for our UVs, I'm not sure how much precision we need for those, but it's definitely not 32 bits. Can we do 16-bit float on GPU? So 16-bit float on GPU. OpenGL vertex attrib. Let's see. So 16-bit vertex texture coordinates have been in OpenGL and ES since the beginning. Just use GL short, which is a signed 16-bit number. And then you can have the values normalized and provide them via that. Then scale them within your vertex shader accordingly, whether they are normalized or not. Okay, so let's check this out real quickly too. So this is basically what I'm going to do, and hopefully that should reduce it quite a bit. So let's see. So we can do unsigned short, which I thought, so let's see, what's GL unsigned short real quickly? Couldn't we discard most of the vertices since the chunk and just leave the outer shell? We could. And I've thought about that too. The problem, I don't know. I think that's probably what I'm going to have to end up doing since we're not using all the vertices and stuff, and just sort of have it be dynamically sized and just regenerate it. What I wanted to do was have it so that when you're updating chunks and stuff, you don't need to reallocate more size, but it looks like we might not be able to do that. So I'll have to look into that. I'll probably do some research in this week in my off time and stuff and figure stuff out. But for now, we can definitely make it a little bit better just by doing this stuff. So this will definitely save us a lot of space and should make it a little bit easier. So this says how to use unsigned short. So this says you can do like that. And I guess in unsigned short, let's see, 8-bit integer OpenGL. Let's see, do they have that? I don't know. How big is unsigned short? Okay, so an unsigned short is 2 bytes. Okay, and then a short is 2 bytes, and an unsigned char is 1 byte. I don't think OpenGL has unsigned char. Yeah, so it looks like, oh, we can do unsigned byte though. Okay, cool. So that's what we'll want to do. This will give us smallest space possible. And then for this, we'll change this to a short. And that should give us better efficiency too. And then if we go into our chunk H, we can change this to be a vec2. Let's see. Okay, yeah, so we can do float 16 too. So let's do f vec2. Let's see, float 16. No. Vec2 16. Maybe. Okay, so we've got I16, I32, I64. But what about just regular vectors? So U16, UVec2, vec2. I don't know if we have any half floats. Yeah, I don't think you can do a half float, so we'll just leave this for now. This should still save us a lot of space though, and I'm gonna have to look into just how to compress this even more and everything. And who here watches Curb Your Enthusiasm? And if not, Larry David is the best. I haven't seen that. I'll have to check it out now though. I've got a long list of stuff that I have to look at and everything. But yeah, so if we change this, that should help us out a little bit. For now, I'm just gonna leave this as it is. We're going to do that. I'm gonna do this back to like a 2x2. And then generate it and everything. And I'm just gonna make sure that I can change it to use a face instead. So this will be just a int, actually a uint, since we're doing that. And this is gonna be a face. And will go out is going to be a flat f face, and then we'll take in a flat f face, and then we'll create a function in here that just says vec3, and this will be like what, face to vec3 or face to normal, and this will take in a vec3, or I guess just a uint face. Yep, and then this will put out. Okay, yeah, and then we should be good there. Let's see. So then if we just, I don't know if we can do this too. I think this might have to be like void, and then we have to say like out vec3 face or normal. Okay, so that's sort of how shaders work, and then we can just say switch on face, and we'll say case uint 0 normal equals vec3. So we'll do 0 is just we'll just do like this, like 0 0 minus 1 break, and then we'll say case uint 1 is normal equals 0 0 1 break, and all the other stuff. So this will be normal equals 0 minus 1 0 break, case uint 3 is going to be normal equals vec3 0 1 0, and then 4 is going to be normal equals minus 1 0 0, and lastly 5 is going to be normal equals 1 0 0. Okay, cool. So that should do everything we need. And he's the co-creator of Seinfeld. I've also never seen Seinfeld. So I've watched Everybody Loves Raymond. That's sort of the show that I would watch, like sitcom. Yeah, but I've been wanting to watch like Seinfeld and Friends for a while now. Okay, so we basically just get the normal here. And what we can do is say, so we have this f face instead, and we used to use f normal, but instead we'll use normal, and we'll say vec3 normal. I don't know if we can do that, we'll find out. And then we'll say face to normal, and we'll pass in f face and normal. Okay, so that should be everything we need for that, if it all works properly. And then we just need to change this up a little bit. So chunk.h or chunk.cpp. If we just go into here, we can say, let's see, what did I make these? So 0 is left. So this is left, right, and I'm going to make this a uint 8 instead. Let's see. And then we have 2 and 3 is top and bottom. So I think actually this should be 3. This should be 2. Yep, so bottom is 2, top is 3, and then 4 and 5 is back and front. So this will be 4, and this is 5. Okay, and then we can just use the cube face instead of what we did here, which was, yeah, so we have this get normal function. We can just get rid of this, and we can just use the face directly. So we'll say change that to face, change that to face. Okay, and let's see, equals, what's wrong with that? So uint 8 vertex face, what's this taking? This is taking a cube face. Yep, so that should be fine. Oh, and I just have to change this to, well, I guess it doesn't matter too much because it is a uint 8 anyway, so I'll just cast it here. So we'll say uint 8. Okay, so this should still work the same. Let's just make sure it works, hopefully. Yeah, I had a feeling that the shader compilation would fail. Okay, so undefined variable f normal, a normal. Oh, cool. So I just have to change this to f face, a face. Okay. Let's retry that real quickly. Yep, so then we get implicit cast from uint to vec3. Okay, so where am I implicitly casting from uint to vec3? So this takes in a uint face out vec3. We switch on face. Oh, this should be uint. Okay, that makes sense too. Cool. So then if we try this again, we'll eventually get there after we work through all the shader areas. Okay, so narrowing of type from vec3 to uint. I think I also forgot to change it over here. Yeah, this should also be a uint. Okay. Run this again. Just gotta fix that. Okay, there we go. Compiled. Okay, so that did not work. Yeah, that's really weird. Oh, is it because I changed like the shader, the float or something? Wow. Yeah, that's really strange. I have no idea what's going on there. It looks like the normals are working though. That's good because it's darker over here than it is over here. So yeah, cool bugs, right? Okay, let's go ahead and see what the heck I messed up. I think it's just the way I'm generating. Let's see. Go back down. Yeah, right here. So this is an unsigned byte. I think that's fine. Oh yeah, I changed this to short. This should still be a float. Okay, so if we do this again, we should be fine. Okay, yep, so we're fine. It's just, I think we're loading in some chunks and then generating some chunks. Not quite sure what's going on there. Or maybe I am still messing things up. Let's see. So this should just be an unsigned byte, and we should just have one of them. That's true. And then we have two GL floats. Is that true too? Yep, so this is GLM vec2. Maybe we just switch the position of these. Don't know. I don't think that shouldn't have any like indication on the position of the blocks because we still get, yeah, the face right there. And yeah, I haven't watched Seinfeld. I'm not that young. I'm like 23 or almost 23, I guess. Yeah. So, but I don't know. I was never into that type of stuff growing up. It was more just other shows. Oh, you're 34. Okay. I guess I am a little bit younger. You're as old as my oldest sister, though. I guess you're just a few years older than her. But yeah. And is it that hard to get a job in the USA? You're 14. Programming job at 14? Yeah, it's very hard. But you could get like a job as a bagger at a grocery store or something. It's still pretty hard if you're 14, but I worked in a grocery store when I was 16. And we had some 14-year-olds who were working there. And they did like different jobs in the grocery store and stuff. So, yeah. It is definitely harder when you're 14, though. Gets easier as you're older. This is pretty weird though. I don't get why this is messing up so bad. So an unsigned byte, let's see how big that is. I'm assuming that's just one byte because that would make sense. Byte open GL. I mean, it's just got to be, okay. If you pass unsigned byte as an integer vertex attribute to a vertex shader, then it's read as a uint type, which is 32 bits in size. Okay, so it doesn't deal in size types, not size types smaller than 32 bits. It only has signed, unsigned floats. If you pass in an unsigned byte as an integer, it can be read as a uint type, which is 32 bits. Passing integral attributes requires the use of that. The vertex shader can then pass it as a uint type, but only then, okay, yeah. So that's what's happening. So this uint is expecting a 32-bit integer. So it looks like we can't use unsigned byte. We just have to use unsigned int. And then we would have to go back into our chunk and change this to be a uint 32. And then we would also have to go up to here. So that's kind of sad. That means we can't use smaller areas, but we'll find some tricks to make this better. So if I do that, we should be pretty good now. Okay. So yeah, it looks like, did we fix it? No, we did not fix it. Okay. It's still going kind of wrong. So this is now a uint 32. This is a uint 32. Okay, so that's all fine. And this is all extending from uint 32. Okay. And if we go back down to here, this is one is a GL unsigned int, which should be 32 bits. And we use offset of, so we shouldn't have any problems there. Yeah, so this is really weird. Am I doing something weird here? I say generate render data, and then serialize. Yeah, so nothing weird here too. Huh. I might have to do some debugging off camera a little bit later this week to figure this stuff out, because yeah, this stuff can become annoying. Oh, this is what's going on. We have to change that too. I don't think this would affect it though. Let's see, just change that to face. That shouldn't affect what we were getting though. I think it's some problems with the offsets and everything. Maybe I'm wrong though. Maybe this will work. Yeah, it looks like this still didn't work quite right. Yeah, so it looks like something's going weird with just the positions, and I'm guessing it's probably has to do with the offsets. It's got to do with the offsets and stuff. But it could be something else too. I don't know. If it was working right, it would be pretty cool, but I don't think it's quite right. Yeah, because it's definitely messing something up over here with this chunk. Okay, but anyways, I think I'm probably going to end the stream right about here. Do you guys have any recommendations for how you think I could shrink the data? Because I think Langors, you mentioned I should only have like, only store the vertices that I'm actually using, which I think is a good idea. So I should refactor this to only store up to a certain amount and then dynamically resize it as needed. I'll try and resize this a little bit more too to make it as small as possible. And then I'll also get rid of the elements to save a bunch of space too, because we don't really need those. But yeah, if you guys have any other suggestions and stuff, just leave it in the Discord if you're part of the Discord, and I'll take a look at that. Yeah, thanks for watching though, guys, and it was good time. I enjoyed this stream, and it was fun seeing all of you. So hopefully I'll see you next week on Saturday at 9 a.m., and I'll probably be doing some random streams throughout this week at like 5 p.m. Central Standard Time. So if you are available and you see it going on, it would be cool to see you guys there too. All right, I'll see you next time.